Next. Okay. And now I like to welcome Arnav Chaudhary Mithun for presenting your paper, Balancing a Parallel Assembly Line Using Kilbridge and Wester Method, a case study on garments factory of Bangladesh. A student of our university from the Department of Industrial Production Engineering.
123.
Welcome, Arnav Chaudhary.
Hello everyone. Welcome to our presentation, Balancing a Parallel Assembly Line Using Kilbridge and Wester Method, a case study on a garments factory of Bangladesh. Myself, Arnav Chaudhary Mithun. My co-author is Saurabh Kumar Ghosh. We are from Department of IP, Bangladesh University of Textiles. Here is our presentation outline. We will talk about introduction, problem statement, methodology, results, and conclusion. In introduction, our main focus is in line balancing. Line balancing is an important part of production. It is a production strategy. It involves balancing operator and machine time to match the production rate to the takt time. What is takt time? Takt time is the rate at which parts or products must be produced in order to meet customer demand. For a given production line, if production time is exactly equal to takt time, then the line is perfectly balanced. Otherwise, resources should be reallocated or rearranged to remove bottlenecks or excess capacity. Problem statement. There are many garments factories in our country. Most of them uses parallel assembly line as their major production strategy. In bottleneck processes, it might be helpful. Smooth flow of materials is ensured by parallel assembly line, but this assembly technique is found less efficient and costly. We'll talk about that later. Methodology, we divided this research in two segments. First, we assess the existing problem. In existing problem, we analyze the obvious report, precedence diagram, parallel station diagram with capacity flow, and calculated all scenarios. And then we applied Kilbridge and Wester method. Here we assigned stations, assigned processes into stations, and calculated efficiency and cost. Methodology. First, we assess on existing problem. Here you can see from OBS report, operation breakdown sheet report. So existing lines layout is shown. Here almost 24 operations in making a t-shirt. Later on, assembly value of each processes is shown here. There are 24. I already told you that there are 24 processes in making a t-shirt. Here you can see operation 4, 5, 14, 16, and 20 are most likely bottleneck processes. It is our precedence diagram of the existing line. We have also calculated capacity flow of this parallel station diagram. Here you can see 4, 5, 14, and 16 merged with 15 and 20. Process is parallelly shifted. So then later on, we applied Kilbridge and Wester method. We assigned all 24 stations, processes into stations. We calculated desired cycle time equal to total operating time per day divided by desired output rate equal to 0.77 minute. Maximum cycle time equal to 8.97 minute, which is calculated from obvious report of our factory. And minimum cycle time, we found 0.78 minutes. So cycle time will be 0.78 minutes. Daily target output rate equal to total operating time per day divided by cycle time equal to 160 approximately for one station. If we calculated 24 stations, we have found 1,846 approximately. So maximum output rate will be 1,846. Theoretical minimum number of stations will be 12. Here cycle time is 0.78 minute again. We assigned all 24 processes into 14 stations through some calculation, which is introduced by Kilbridge and Wester in in 1846. Later on, in result parts, from our calculation after studying factories parallel assembly line, we found maximum line balance efficiency is 42.4%. Labor cost per day is 40,320 taka. Whereas Kilbridge and Wester method gave us percentage idle time of 18%, which leads to line balancing efficiency of 82%, and cost calculation is 20,160 taka. Conclusion, in parallel line, the efficiency was 42%. 82% efficiency is obtained by using Kilbridge and Wester method, and the labor cost is reduced by 50%. We can also use work aids to make line more balanced. In future, other heuristics method and advanced simulation should be used. It is a simple study which shows comparative study between parallel stations and Kilbridge and Wester method. I have found Kilbridge and Wester method more efficient and costly. Feel free to ask questions. Thank you all.
Thank you for presentation. Please ask someone if you want to know something. Anyone? Okay. Okay.
Can you explain the Kilbridge and Wester method actually?
Sure, sir. Sir, first I have to calculate the total operating time per day, which is 3 into 8 into 60. I have 3 shifts in a day, 8 hours in a shift, and 60 minutes, and divided by desired output rate, which is 870, which I found from factory's OBS report, which leads to 0.77 minute. But in my process, here you can see in 24 processes, maximum bottleneck process is 4, which is almost 0.78. Below 0.8, which is almost 0.78. So minimum cycle time is 0.78 and maximum cycle time, which I have calculated from summing all the processes, is 8.97 minutes. So the cycle time will be 0.78 minutes. That means I have to assign each station worker to work in that time, which is 0.78 minutes. And maximum output rate would be 846, which is lesser than requirement, but it leads to more cost efficient and efficiency. There is a long chart I have given in my paper. I didn't feel it required to be on my slide. So I have, if you give me some more time, I can explain all the table that I have divided these processes into stations.
Okay, thank you.
Thank you.
We are confused actually. You have written this is methodology, yes, but you have given your result. This is the problem. Okay. Yes.
Thank you.
Thank you.
You have a good cost reduction approach through Kilbridge and Wester method, and that's really good study. So I'm curious that did any garments industry production line apply your findings in their actual production?
Sir,
yet?
actually, it is a part of my industrial attachment.
Okay.
I have studied in my garments line, but I am trying to apply or approach garments to apply this Kilbridge and Wester method instead of parallel line balancing, but hope in future I can.
Okay, thank you.
Okay, I have one question.
Sure.
What are the tools you use for Kilbridge and Wester method in your study?
In Kilbridge, the main theory is lowering the percentage idle time. In a station, when a worker works, he can do one process only. That is like here, we can see in station 2, 3, 6, and 17 process is done by one worker. In station 1, 1 and 2 process is done by one worker. So one worker have to do those processes like 1 and 2 in 0.78 minute. So we have to assign stations according to time limit, which is 0.78. One by one, and then calculated the percentage idle time mainly, which is 18%, and then line balancing efficiency is 100 minus 18%, leads to 82% efficiency.
Okay, thank you. Okay, thank you very much. I think you will go better in future. Nice presentation.
Thank you.
Thanks.
Thank you, everyone.
Okay, we have seen already 3 papers. I think in Bangladesh we are doing something for research. We are thinking about our garment sector. This is our export earning sector. We are studying in this paper. We have seen they are studying how they can minimize time, how we can increase our production. Actually, in this region, Southeast region, the productivity of our garments is lower than compared to another country. There are probably many things related to this, but we are trying to solve it. In the meantime, some different technologies are coming in our sector, and the positive sides of us is we can accept it, we can operate our sector. This is most valuable things. We can accept modern technology, and our operator and management can receive and think about for the development of our sector. But I am thinking always about wastage of our garment sector. I am always thinking about wastage. We are creating so many wastes, hard waste, soft waste. In next time, I think we will think about minimization of our wastage.